You know what's fascinating about the future of robotics? If humanoid machines truly become part of our daily world, the biggest shift may not come from smarter software, but from physical robots that can walk, work, and operate in human spaces. Tesla is building Optimus Gen 2, a robot designed around long-term scale, AI-first learning, and the vision of a mass-market labor machine. Unitree is delivering the G1, a compact humanoid focused on accessibility, articulation, and real-world deployment in labs, research, and development environments. Now, instead of getting lost in hype, demos, or brand loyalty, we're stepping back to examine what truly matters. We're comparing Tesla's Optimus Gen 2 and Unitree's G1 through specifications, maturity, AI philosophy, hardware design, and realistic use cases, all to answer a deceptively simple question. Which humanoid robot is actually leading the race? Size, weight, and design. Let's start with something fundamental. Physicality, because in humanoid robotics, size and weight define everything. Balance, stability, actuator demands, payload capacity, and even cost. Tesla Optimus Gen 2 stands at roughly 1.73 meters tall, placing it squarely within adult human proportions. Weighing around 55 to 57 kilograms, it is engineered to function as a full-scale labor machine, designed to operate within environments originally built for humans. Doorways, workstations, factory aisles. Optimus is meant to move through them naturally. Its design language is unmistakably Tesla. Smooth surfaces, minimal visual complexity, and a form factor that feels closer to consumer electronics than traditional industrial robotics. Unitree's G1, by contrast, is intentionally compact. Standing around 1.3 meters tall and weighing roughly 35 kilograms with battery, G1 feels more like an adolescent-sized humanoid. This smaller scale is not a limitation by accident, it is a strategic decision. A lighter robot demands less torque, less power, less structural reinforcement, and significantly lower hardware cost. It is easier to transport, easier to recover from falls, and easier to integrate into lab environments. Where Optimus is designed to fit into the human workforce, G1 is designed to fit into the research ecosystem. Motion and mechanics. Movement is where humanoid robots reveal their true engineering depth. Tesla claims Optimus Gen 2 is approximately 30% faster and significantly lighter than Gen 1. Its walking speed, estimated around 2.1 meters per second at peak, positions it as stable, controlled, and efficient rather than explosively dynamic. Optimus is not trying to win sprinting contests. It is trying to work all day without wasting energy. Tesla's actuator strategy prioritizes efficiency and integration. Every joint is powered by Tesla-designed electric actuators, combining motors, gearing, and sensing into tightly optimized units. The emphasis is clear: durability, cost optimization, and industrial reliability. Unitree G1's movement philosophy is different. Thanks to permanent magnet synchronous motors and configurations offering up to 43 degrees of freedom, G1 showcases fluid, highly articulated motion. Its smaller mass allows surprisingly agile, walking, and natural-looking body dynamics. But the real advantage lies in articulation density. Extra waist freedom, wrist flexibility, and optional dexterous hands give G1 a level of expressive movement that researchers love. It is less about brute strength and more about motion versatility. Optimus moves like a worker. G1 moves like a platform for experimentation, power, and runtime. Battery design quietly defines a robot's usefulness. Tesla Optimus Gen 2 is powered by a battery pack around 2.3 kilowatt hours. Tesla frequently describes this as enabling all-day operation, though realistic expectations vary depending on workload, duty cycle, and task intensity. Heavy lifting drains faster. Light inspection lasts longer. Tesla's goal is clear: industrial endurance. Unitree G1 operates in a different regime. With its 9,000 mAh quick-release smart battery, runtime typically sits around 2 hours. That sounds modest, and for continuous factory labor, it would be. But G1's battery is swappable. This changes the equation entirely. Instead of waiting for recharge cycles, operators can simply replace the battery and continue operation. For labs, demos, and research sessions, this flexibility often outweighs raw endurance. Tesla optimizes for long shifts. Unitree optimizes for modular workflow, sensors, and perception. Here, the philosophical divide becomes dramatic. Tesla Optimus Gen 2 adopts Tesla's signature camera-only perception strategy. No LiDAR, no depth scanning towers, just vision. Multiple cameras feed neural networks adapted from Tesla's full self-driving stack. These networks perform pose estimation, object recognition, navigation, and environmental understanding. Tesla's belief is bold: Vision plus large-scale neural learning will outperform expensive sensor redundancy. Advantages include lower hardware cost, fewer components, and continuous improvement through AI training. But this approach also carries risk. Vision-only systems struggle in edge cases, poor lighting, reflective surfaces, occlusions. Unitree G1 embraces a more classical robotics stack. LiDAR for precise spatial mapping, Depth cameras for structured perception, IMUs for motion awareness. This sensor fusion approach is extremely attractive for research because it supports SLAM, reproducible experiments, and direct control pipelines within ROS ecosystems. Tesla bets on data scale. Unitree bets on sensor precision, computing, and AI. Tesla Optimus Gen 2 is powered by Tesla's proprietary AI infrastructure. Training draws from teleoperation, human demonstrations, factory data, and Tesla's vast vehicle fleet vision priors. The robot benefits from Tesla's Dojo, supercomputing ambitions, and neural network expertise. But Optimus is closed. There is no public SDK, no ROS access, no developer kit. External engineers cannot simply purchase Optimus and experiment freely. Unitree G1 is almost the opposite. Built around high-performance CPUs and often NVIDIA Jetson Orin modules, G1 is designed for developers. ROS and ROS2 support allow researchers to access perception, control, and behavior layers directly. This openness has enormous implications. Students learn on G1, researchers publish on G1, developers prototype on G1, Tesla controls the stack, Unitree shares the platform. Dexterity and manipulation. Tesla Optimus Gen 2 features hands with 11 degrees of freedom each and tactile sensing. Demonstrations show delicate handling, small object sorting, and human-like grasping behavior. Payload estimates around 20 kilograms place Optimus in real labor territory. It can lift boxes, carry parts, and handle industrial materials. Unitree G1's payload is far more modest, typically around 2 to 3 kilograms per arm, but its optional dexterous hands, hybrid force position control, and high articulation make it ideal for manipulation research. It may not lift heavy loads, but it excels at experimentation involving grasping, teleoperation, and learning algorithms. Optimus is built to work. G1 is built to explore possibilities, pricing, and market. This is where theory meets economics. Tesla's Optimus Gen 2 is not commercially available yet. Tesla's long-term price target, often cited between $20,000 and $30,000 US, is potentially revolutionary. If achieved, it would redefine humanoid affordability. But as of early 2026, this remains a promise. Unitree G1 is real. Base configurations begin around $13.5 thousand to $16,000 USD, with higher EDU variants scaling upward depending on compute, DOF, and accessories. For anyone needing a humanoid robot today, G1 is one of the most accessible entry points. Maturity and deployment. Tesla Optimus Gen 2 operates inside Tesla factories performing controlled internal tasks. This provides valuable real-world data but limits external validation. Unitree G1 lives in the wild. Universities, labs, conferences, demonstrations. It benefits from diverse user feedback and an evolving ecosystem. Tesla demonstrates ambition. Unitree demonstrates availability. Tesla Optimus Gen 2 and Unitree G1 are not simply competing robots. They represent two visions of humanoid robotics. Tesla pursues scale, autonomy, and AI-driven disruption. Unitree delivers accessibility, openness, and immediate practicality. Optimus Gen 2 may become the most disruptive humanoid ever built if Tesla delivers on price, reliability, and mass production. But today, for researchers, developers, and institutions needing real hardware, Unitree G1 holds a decisive advantage. Because the future is not just about potential, it is about what you can actually use right now. So now, the debate shifts to you. Which future do you believe in? Tesla's AI-first, mass-market humanoid revolution? Or Unitree's open, developer-driven robotics ecosystem? Tell me in the comments.